There are two fundamental laws of refraction. The first law states that the incident ray, refracted ray, and the normal to the interface of the two media all lie in the same plane. This means that the path of light remains in a single plane when it moves from one medium to another medium. The second law of refraction states that the ratio of the sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. Sine I divided by sine R is equal to constant. This constant is called the refractive index. Refractive index. Refractive index of a medium is a measure of how much the light bends in this medium when it enters from another medium. 1 mu 2. Refractive index of the second medium with respect to the first medium. The ratio of sine of angle of incidence to sine of angle of refraction is equal to the refractive index of the second medium with respect to the first medium. Let's solve an example. A light ray travels from air into glass. Air is a rarer medium and glass is a denser medium. If the angle of incidence in air is 30 degrees and the corresponding angle of refraction in glass is 19.5 degrees, calculate the refractive index of glass with respect to air. You can see here that angle of incidence is 30 degrees and angle of refraction is 19.5 degrees. As light travels into the glass, the speed will decrease and it bends towards the normal. Now the ratio of sine of angle of incidence to sine of angle of refraction will give us the refractive index of glass with respect to air. We can substitute appropriate values. Sine 30 divided by sine 19.5 is equal to 0.5 divided by 0.333, which is equal to 1.5. So the refractive index of glass with respect to air is equal to 1.5. The deviation can also be calculated easily. Deviation delta is equal to I minus R. Angle of incidence is 30 degrees minus the angle of refraction, which is 19.5 degrees. So this is the deviation. Deviation is 20.5 degrees. Let's solve another example. A light ray travels from air into glass. If the angle of incidence in air is 45 degrees and the corresponding angle of refraction in glass is 28 degrees, calculate the refractive index of glass with respect to air. This is similar to the previous problem. Only the values have been changed. The angle of incidence in this case is 45 degrees. Light bends towards the normal as it enters the glass. It slows down and therefore it bends towards the normal. Now the ratio is sine I divided by sine R, that would be sine 45 divided by sine 28. 0.707 divided by 0.469 gives us 1.5. So refractive index of glass with respect to air remains the same. Okay, the value is 1.5. It's a constant quantity. Deviation is I minus R. In this case, it is 45 degrees minus 28 degrees, which is equal to 17 degrees.